Dear students, already we have covered what is the elasticity, the property of the material, and what are the different elastic constants. We know well that what is Young's modulus, what is rigidity modulus, what is bulk modulus. The three different elastic constants are Young's modulus, rigidity modulus, and bulk modulus. In this class, we discuss the relationship between the three elastic constants Q, the Young's modulus, N, the rigidity modulus, K, the bulk modulus. Consider the three stresses. The stress means the force acting on area. Three stresses acting on a cube-shaped isotropic material. What is cube-shaped isotropic material? It appears like a cube. It is made up of isotropic material. So elastic material. Isotropic means if you apply a force in one direction, its effect will appear in all other directions. This type of material is known as isotropic material. Now we are applying three forces. The P, Q, R. P is the one force, Q is also a force, R is also another force. We are applying three forces, three stresses on this isotropic cubic material. The three forces, the three stresses acting perpendicular to the face of the cube. Which one is face? A, B, C, D is a one face. Okay, and then A, D, H, E. It is the another face. It is the first face. It is the another face. Next face is A, B, E, F. This area, this face. It is the first face. It is the second phase. It is the third phase. So, the three forces P, Q are acting perpendicular to the phases. Phase A, B, C, D, A, D, H, E, A, B, E, F. Okay. So, the three stresses will produce extension. The extension is indicated by the symbol lambda, and the contraction is indicated by the symbol mu. Here, when we apply a force or when we apply a stress, the isotropic material cube expands. The expansion is indicated by lambda. At the same time, the contraction is indicated by mu. So now let us consider lambda is a extension per unit stress. When you apply a force, it will extend. Extension will be appear. So the length will be increases. At the same time, the contraction mu is the contraction per unit stress. So length will be reduced. Okay, it is known as contraction. It is expansion. It is contraction. Length will be increase. Length will be decrease. For the stress, already we know that there are three types of stress. P, here P is applied in this phase, Q is applied in this phase, and R is applied in this phase. So this one. Okay, there are three forces. So P is applied here and here. Q is applied in this phase and in this phase, and R is applied in this phase and this one. Okay. For step 1, suppose consider a force P only applied in this direction. See here, the P is applied at the face A, B, C, D and E, F, G, H. The force, the pressure is applied here. So this cubic isotropic material changed into this shape. See here, the force is applied in this direction. So this length increases. It is an expansion. It is indicated by lambda along the direction of the force P applied. At the same time, this length contracts, reduces. It is indicated by mu. At the same time, this length also contract, compress. So this length also reduced. It is indicated by mu. When we apply a force in P or stress in this direction, the length of lambda increases, the expanded, and the other two directions are reduced. The length of the other two directions are reduced. They are compressed. It is indicated by the symbol mu. So when we apply a stress P, the elongation E is equal to lambda into P. Lambda is the expansion in the direction of stress P. It is lambda P. Why it is put minus? So length is reduced, minus mu into Q. So mu is the contraction. So length reduced in the direction of Q, in this direction. At the same time, the length in the direction of stress R also reduced in this direction. So it is indicated by minus mu R. So in the direction of P it expanded, in the direction of stress Q and R it is contraction. So we can write the equation elongation is equal to lambda P expansion minus mu Q contraction minus mu R contraction. Now we are applying a force, a stress along direction Q. So see here. So we are applying a stress or a force along this direction Q on this isotropic cubic material. On applying a force, a stress along this direction, this cubic material is changes like this. So it expands. The length of this cubic material expands along this direction Q. So it is indicated by the value expansion lambda. So the length increases here. It expands. At the same time, in the direction of P. So it is the P direction. So P stress direction. So in this direction, the length contracts, compressed, decreased. So it is indicated by mu. At the same time, the length in the R direction, it also reduced, compressed. So it's also indicated by mu. So the equation after applying a stress Q is given by F is equal to lambda Q. So it expands and minus mu P in this P direction minus mu P and in the R direction minus mu R. In the same way, the stress, the force R is applied in the R direction. The force is applied in this R direction in the face AB, EF and CD, HG. In this phase, the force, the stress R is applied. On applying a stress or force R in this direction, the length in this direction increases, so it expands in the direction of R, and the other two directions are compressed, reduced. So the equation is written as G is equal to lambda into R minus mu into Q, the Q direction, and mu into P, the P direction. So G is equal to lambda R minus mu Q minus mu P. Now consider the stress P only acting. So the R is equal to 0. Then we have only longitudinal stress P and the linear strain. The equation E is equal to lambda P minus Q mu Q minus mu R. The R and Q is taken as 0. So this term cancelled. So E is equal to lambda P. We know well that the Young's modulus Q is equal to longitudinal stress by longitudinal strain. So longitudinal stress, the force is nothing but P. The strain produced is lambda P. So PP gets cancelled. We will have Q, the Young's modulus Q is equal to 1 by lambda. It is taken as equation number 1. This otherwise it is written as lambda is equal to 1 by Q. In the second case, suppose Q only acting. Suppose the stress R is equal to 0 and P is taken as minus Q in the opposite direction of the force. Q is acting in opposite direction of force P. Then this equation is modified into E is equal to lambda plus. Suppose this equation E equal to lambda P minus mu Q minus mu R. R is taken as 0. This term is eliminated. P is equal to minus Q or Q is equal to minus P. So Q is substituted with minus P. So this minus get plus. So lambda P plus mu P. We get E is equal to lambda plus mu into P. We know that the shearing strain or the angle of shear phi is equal to 2E is equal to 2 into lambda plus mu into P. From this, we can calculate the rigidity modulus N equal to tangential stress by shearing strain. So on substituting these values, so we get P is the stress, and so P gets cancelled. So N is equal to 1 by 2 to lambda plus mu. So E is equal to lambda P minus mu Q minus mu R. So on substituting this value, we get this one, and we know that the rigidity modulus is equal to tangential stress by shearing strain. On substituting this value, we get this equation 2. This equation 2 is nothing but 2 into lambda plus mu is equal to 1 by N. N is the rigidity modulus. Now we go to the case 3. Here the P, Q and R, the three stresses, the three forces are equal. Then on applying this condition to this equation, we get E is equal to lambda minus 2 mu into P. We know that the volume strain or bulk strain, it is applied in all direction. It is given as 3E is equal to 3 into lambda minus 2 mu into P. We know that the equation for the bulk modulus K is equal to bulk stress by bulk strain. We know the bulk stress, it is nothing but P. The strain is already calculated. It is 3 into lambda minus 2 mu into P. On solving this equation, we get lambda minus 2 mu is equal to 1 by 3K. It is taken as equation number 3. From these equations 2 and 3, we can get the relationship between the Young's modulus, rigidity modulus and bulk modulus from equation 2. This equation 2 into lambda plus mu is equal to 1 by n. It is modified into this equation. We know the equation 3. On adding to this equation 2 and equation 3, we get 2 lambda plus lambda 3 lambda plus 2 mu minus 2 mu gets cancelled, 1 by n plus 1 by 3k. On simplifying this equation, we get lambda is equal to 3k plus n by 9kn. So we know from the equation 1 that q is equal to 1 by lambda. Lambda value is given here, 9kn by 3k plus 1. This equation relates the three modulus, Young's modulus, rigidity modulus and bulk modulus. This equation Q is the Young's modulus, K is the bulk modulus, N is the rigidity modulus. So this equation Q is equal to 9kn by 3k plus n gives the relationship between the Young's modulus, rigidity modulus and bulk modulus.